I just very recently found this about the Gaussian training. The PostShot program have been very great because it has this live preview where you can really see how the Gaussians are generating and how they are building themselves. If you push the play button in the timeline, you will start to see those very dynamic Gaussian placement that the Gaussians start to wobble around and they will go on their places very dynamically.
Welcome to a new episode of XR and AI Spotlight, the show that gives the stage to the founders and creatives pushing the boundaries of XR and AI. My name is Gabriele Romagnoli, I'm your host, and I'm here today with Olli Huttunen. Olli is an entrepreneur, video editor, 3D specialist, software developer, and a real authority when it comes to Gaussian Splatting. I got to know Olli thanks to his YouTube channel, a priceless resource for anybody who wants to dive into this new 3D paradigm. Today, we take a deep dive into the world of Gaussian Splatting. Olli explains why PostShot is his favorite tool and how to make the most out of it.
And you can use 3 different profiles right now. They bit differs from each other.
He shares best practices to minimize file sizes.
Yeah, there are some things that you can do before starting the training or mostly in the afterwards. They have developed this called SPC, kind of a new format for that, and they have open sourced it. Inside the spherical harmonics layers, there are the quality, the photorealistic quality comes out from that data. But it is very heavy. Only in you have the ability to check out and remove those layers from it.
He tells us about a Blender add-on he has developed to create virtual camera array and why actually turning a mesh into a Gaussian splatting is not such a dumb idea.
So the camera array tool, which I have developed for the Blender software, it is an add-on which makes you create this kind of virtual world camera array setup and render images out from all those cameras and image data. For example, for the Gaussian splatting training. And then what's the benefits in this? And I had to explain that even though it sounds dumb, there are several good benefits in there.
And how the capabilities of the same camera array tool can be pushed even further to create 4D synthetic Gaussian splatting.
When we are inside the Blender and these 3D software, you can render also the animations. But with the camera array tool, you can render all the images from each frames. And basically, these 4D GS models are only a sequence of these PLY files.
But before we get into it, I wanted to thank our sponsor Meshy, who made this episode possible. Meshy is a real powerhouse for generating 3D assets with AI. You can start with a simple text or image prompt and get high-quality, stylized 3D models in just a minute. There are 2 features that completely blew my mind. One is the ability to create stylized texture for any mesh, with or without UV. And the other is the ability to edit portions of AI-generated textures like in Midjourney in Painting. The team has been pushing continuous updates, improving significantly the geometry and texture quality, and I strongly encourage you to visit meshy.ai and check out the generous free plan. After that, make sure to use the code XRAI20 to get a 20% discount on your subscription. And now it's time to roll the title and welcome Olli under the spotlight. Olli, it is a real pleasure to have you here.
Yeah, thanks. Thanks for having me.
So, Olli, on your channel, you have been exploring so many tools and creating so many resources for people to capture, manipulate, and in a way get the most out of Gaussian splatting. So I would like to start by asking you, you have worked with platforms like PostShot, Nerve Studio, Luma AI, and more. So how do these pipelines differ? For example, in terms of the use, the flexibility, and maybe the quality that you get out of it?
Yes. Recently, I mostly have been working with this PostShot program, which is this local Gaussian training program that you can use on your PC computer and in the Windows environment. And I believe that is the most easiest way to use those programs at the moment, it gives you lots of opportunity to change the settings and mix all these parameters in there. But then, of course, there are these very easy to use online services like this Luma AI that you mentioned. Luma AI isn't anymore that usable as they have focused more on their platform on these AI video generating things. And this moment when they offered the Gaussian splatting calculation services on their platform have been kind of a past time right now on theirs. Their service is still in there, and these interactive scenes, as they call it, they can be found in the website, but they don't actually provide the service time anymore.
And by the way, they call it interactive. They are not really interactive in a way, in a sense that they are some of the best animation for Gaussian splatting that I have seen. When it comes to the initial wow effect, still unmatched. But right now it's very hidden. You really need to dig in the website to get access your library.
Yeah, and if you made some models, you can still find your models in their service, but it's really hidden in there. But after all, the Luma AI was the best viewers in the field, and I believe it still is. It's a very, very nicely coded Gaussian splatting viewer online, and I believe that interactive part from there, they came from only that you could really fastly upload those models to your web services and use those and rotate those models in almost anywhere, because there was also this option to embed those 3D models for example, on your own website and use it that way also. But then there are these another competitors like a Polycam service, which is very good also, and then there is this Chinese competitor. There's this Kiri engine, which I noticed that you also interviewed the Jack in your previous episodes, which was very interesting to listen and see. Absolutely. All those.
And for anybody, I think you should check it, because I think it's indeed the more people we have in the space, the better it is. And I think just a shout out, I think they're doing something great when it comes to going beyond just the visualization, but making it more usable. Like, for example, creating meshes. They have also this plugin for Blender. So I think go there, check out the episode, check out what they're doing. But you mentioned one important thing, right? So right now you're using PostShot on your own computer. Maybe what kind of specs do you need in order to run, let's say, a medium range, let's say, let's call it simple Gaussian splatting? So what kind of stats do you need?
Yeah, well, the PostShot is developed on this NVIDIA graphics card. You need to have the NVIDIA GPU on your computer. The RTX level cards are the best, and they run on that system. When the PostShot was first released, it even run on the very mediocre on the 2060 RTX type of cards, and my PC is not that special either. I run this very, very average RTX 3070 with only 8 gigabytes of VRAM memory, and I can still run that whole program very well in there. And I have noticed that the developer who makes this PostShot, this Jascha Virchel, has done very good job on the coding and optimizing that it can be run on very average this kind of a 3D accelerated PCs.
And that's actually one important thing, because I think that there is also the ownership of the data in a sense, and I think it's also a very important topic when you upload this. It could be Polycam, it could be Luma, it could be Kiri Engine or anywhere. You are always, let's say, sharing this information, and then what's going to happen, how can this model be used, how can they use the models, while instead when everything is happening locally, and as you mentioned, PostShot being rather accessible in a way in terms of the kind of like specs that you need for the computer, I think it just makes 3D creation more accessible to everybody, and that's, I think, what a lot Gaussian splatting is also about.
Yes, and it's very important that you have also these local possibilities to make these, because nowadays these different companies are interested about making these Gaussian splatting models, and they don't actually many times have this opportunity to upload their stuff to the cloud services that they don't have control of. So this local training is important for those companies, that they can make 3D models through those services and these closed environments on their own computer. But I think that the PostShot is also very, very interesting in that sense, because you have the full control of those parameters, and you can really develop it. It doesn't have all those opportunities that the Nerf Studio has, and the Nerf Studio is, I believe, designed more for the researchers and the developers who really make these algorithms and research on these things, and are very good on these different kind of programming environments, and really know how to type all those commands from the command line and command prompts. It is the Nerf Studio is very, very complicated to use the average user to put on and make those training process through that.
So you mentioned also that you have more control on PostShot, right? So what are maybe some simple example you can give us about things that you can do in PostShot that you can control that maybe you can't when you're using, let's say, an app like Luma or Polycam or so on? What are the control aspects?
Yeah, there isn't that many actually, and it's a good thing when you learn about this. That mainly you can affect on those amounts of how many splats or how many Gaussians are calculated in the process, and you can use three different kind of profiles right now. There is this very new Splat 3 profile added to the PostShot program at the moment, but before that there was this MCMC method, which comes from this mathematical Markov chain Monte Carlo method, and then there was this ADC method, which was the first one on there, and they bit like differs from each other. The Splat 3 and the ADC are mostly this kind of methods where the splats are generated like inside out, and this MCMC method it's like a bit more chaotic. It starts from the outside in, and the splats are shooted from very far to the center point, and the generation of the Gaussian splatting are made from there, and the MCMC method leaves this kind of a lot of these kind of a hidden splats in the model, which can produce also quite large and heavy file sizes on those, and there are these the benefits on each of these methods. But mostly those parameters and settings can be used for the optimizing these file sizes. And when you really learn how many camera angles and how many source images you are building in there, it will benefit how good quality and how kind of a heavy file you are getting out from the PostShot.
And you mentioned a very important thing in a sense that there is always, when we look about visual fidelity, Gaussian splattings are, let's say, outperform in a way what is a standard mesh model, right? Because if the reflections, and there is also this, let's say, indication that it's lighter, right? In terms of megabytes. Yet it is not exactly super light, in a sense that I do love to, for example, view and experience these splats in VR, and it's not always possible yet, in a sense that many of these splats
exactly.
can be huge, and sometimes they are dirty as well, right? Sometimes they just have a lot of floaters. So maybe, like you mentioned, an important thing being file size. What can people do in order to decrease, compress file size, or maybe just clean the assets? What can be done to make this, let's say, a lighter formats that can be experienced or shared more easily?
Yeah, there are some things that you can do before starting the training, or mostly afterwards when the model is generated or trained. There are these image sets that you are putting in there. You really need to go through them, through all those source images, and think about what can be left out, how many pictures you are putting in there for the calculation, and of course there are these automatic methods in built inside in the PostShot also already, that you can even drop these video files in there that you have recorded your camera, these video files, and you can put those videos in there and let the PostShot choose the best images from the video material.
So first thing is understood, right? So the first important is like optimizing the input that goes in it, right? So that means that you need the minimum amount of picture of data in order to generate the best quality outcome you want, right? So this means removing shaky picture or the one that might have a blurry background. And I imagine also like over repetitive, like pictures of the same thing. Maybe you were steady in that point, and maybe those are not just the ideal. So you clean up the input that is submitted, in this case to PostShot, right? So then what else? What else can be done to create a lighter splat?
Yeah. Afterwards, when the Gaussian training is ready, you can also take a look of the model and clean out those areas which you don't need. If you have done these kind of object-centric scans, that you are scanning like a statue or a little object of you, you don't need the surrounding areas or there. And for the calculation, the surrounding pixels and surrounding areas are important, because the PostShot can make those triangular calculation and the camera position data through those background pixels. But when the model is ready, you can really crop out that only the object is in the center, and you can clean out all the background splats out of those, and that of course significantly reduce the file size there. But if it's environment you are having in the model, if it's like a room or some outdoor environment that you have been scanning, then you have to take a look at those possible floating artifacts that you can clean out there. And of course, if you have used the MCMC method, then you have a lot of those hidden splats in there, and then you have different kind of methods to find those and clean them out and to reduce the size. You can use the PostShot program to do that. There is these painting tools with which you can paint the splats, and also the Super Splat application, which can be run in the browser. And the Play Canvas company who have produced that have done a very versatile program out of it, and you can clean the model inside the Super Splat also.
That's fantastic. By the way, for anybody, I've also interviewed Will Iscott from Play Canvas here, so you can check back in one of the previous episodes. Then there is one more question that I have. What about file compression? I have heard that there are different options to go about it. Are there some recommendation or something that you can do in PostShot or outside?
Yeah, well, the compression mainly, it has developed very recently. There are these new formats for that. The Niantic company who produced this Scaniverse app, which is, by the way, the very good kind of a thing that when you want to make Gaussian splatting models with your mobile device, you can use this Scaniverse app. And they have noticed that when people are publishing so many of these Gaussian splat models, they need to be more decent size and easier to handle, and they have developed this called SPC, kind of a new format for that, and they have open sourced it. So anyone who was interested about that, they can start to develop on that standard. That I hope that it will become some sort of a standard. But there are not so many programs, at least that only that Scaniverse app at the moment, which can read these SPC compressed Gaussian splatting files. But one thing is also that because the most of the PLY, this PLY format is the standard format which you can get these Gaussian splatting models out, and the most of the files are written from this spherical harmonics data, which is this information about that every Gaussian in the model will gather some sort of information about lighting conditions and where the lights come from, and then they can produce this really shade great looking 3D model. And inside the spherical harmonics layers, there are the quality, the photorealistic quality comes out from that data. But it is very heavy, and it is the most of the file size comes from that data. If that is written out completely and taken out from that file, the file size gets actually so small that it's very easy to upload in the browser and use it. It affects to the model in that way that it looks quite flat, and it loses some of its characteristics. But I have noticed that in real world scans, it doesn't actually matter that much. That even in some places, in room places or other these kind of real world scans, you can remove the most of these spherical harmonics data. But in special way, when we use the synthetic models from these pre-rendered images, then there are these quality issues that you can really clearly see that, okay, you have to make some compromise about those to keep the spherical harmonics data inside the file.
I just wanted to have a quick break to remind you that if you're enjoying this conversation, you should definitely check out the XR AI Spotlight newsletter. By subscribing, you will get weekly interviews like this one directly in your inbox. And by subscribing, you also get access to a list of tools and apps that allows you to experience Gaussian splatting in VR on Quest and Vision Pro. Just check the first link in the episode description. And now, let's get back to the show.
We're gonna jump into that concept of the synthetic splats very soon. But I do have a question. So what you're saying is that the splats that are captured from, let's say, a real-world environment, one way of compressing them is remove some of those harmonics data that makes for the shininess, for example, for that view-dependent effects. And is this something that is done also within PostShot? I mean, how can you decide how much of those data to remove?
Yeah, well, PostShot always makes the models with the highest quality, and there are 3 layers of those spherical harmonics layers, and actually only in SuperSplat program you have the ability to check out and remove those layers from it. But sometimes it's enough if you just stay with the 2 layers in there, and the quality is still pretty good. You don't have to have all the 3 SI bands or this spherical harmonics layer, as they say in there. But also in PostShot, you can of course check out how the model looks when you take the layers off in it, and you can see that what kind of flat surfaces it has without the shininess and all these view-dependent effects in there. But it always saves the model in with all data in PostShot.
Oh, okay. So then, sorry, Olli, I need to just understand, because as soon as our conversation is done, I need to try. In a sense that you will have this model. You can remove some of these layer harmonics. Let's imagine that I'm in Super Splat. When I download the PLY file, will then be the removed that layer, or it's also still saved in the data when I export it?
When you take this, the SuperSplat program have developed quite fast recently, and now they have these export compression methods in there, and there is this option when you export the model, you can affect to the which SI bench you are taking with it, and through that method you can make different kind of compression sizes to the files.
Perfect. I'm gonna check. Thanks for the clarification.
It's sure very good option that they have added that in there. Before that, they only have the option to use the compressed, and that basically means that it removed everything from the spherical harmonics out of there, and then you got really small, reasonably small file size, but it looked kind of flat, and it loses the qualities in there. But these are these current methods that when before these future compression algorithms develops and somebody comes out with a decent. It would be very cool if this could be remained, that the PLY file will remain, that we don't have to use also another new format in there. But let's see what they are going to make. And
I think another important thing is that maybe the way we're going to consume this kind of content is not necessarily on device, but might be streamed in a sense, right? So when I mentioned, for example, like when, again, trying some very high realistic scenes like the one that are in Hyperscape. So there is this app that Meta built, and in there are 6 samples, but the scans are incredibly good, and nothing loads on your device. Everything is streamed to your device. And so because of that then it's a completely different way of thinking about it. Then at that point, we are talking about different technical challenges.
Yeah, and that comes exactly when we are using these 4D GS models, these dynamic and then the streamable Gaussians are very important when you have movement inside them.
So Olli, let's start with this, because we have discussed so far about scanning, right? But it's not just about scanning the real world, right? So you have created this camera array tool that allows to capture what you call a synthetic splat. So what I want to do is that I want to add a little video so that you can talk over it while explaining what we are seeing and what this concept is about. All good?
Okay, let's try that. Yeah. So the camera array tool, which I have developed for the Blender software, it is an add-on which makes you create this kind of virtual world camera array setups, which they used in these studios in real life to capture all these kind of characters or objects, where they put these characters inside this kind of a camera cage and capture pictures about those subjects from every angle. And with the camera array tool, you can produce this kind of similar kind of a virtual erased rig that you can control in Blender and render images out from all those cameras, and make the image data, for example, for the Gaussian splatting training, and this way you can make Gaussian splatting conversions about 3D models. I have been asked many times that what's the idea behind this? That why would I want to create a 3D model? Because I already have the digital 3D model with me, and then what's the benefits in this? And I have had to explain that even though it sounds dumb, there are several good benefits in there, because the Gaussians can be shown in real time, and when you do the heavy lifting work and all these rendering once, even though it takes time, then when the Gaussian splatting model is ready, you can really see it in the highest quality in real time, like in game engines where they do these same kind of things about calculating accurate shadows and all these lighting environments in the game, just inside the game engine with different kind of gimmicking methods like memory handling and different kind of results. But like in this situation where you have a model where it has a very complicated particle systems to show some hair or fur, which is very, very heavy to calculate or render inside the 3D program. If you do that once and render all these images out from the camera array tool, you can do the Gaussian splatting conversion of that model, and afterwards look at that in real time, even in web browser. And I think that when the people understand this aspect about that, it's a very, very interesting method to make these models from pre-rendered images. And these are called as a synthetic material and synthetic data sets that are made from already made 3D sources.
And so, because as I understand, right, each image is then captured based on the specific light conditions and render of a scene that's been created in Blender. So it is not necessarily just a static 3D model standing there, but there is, if it was, for example, glass or a specific material, that will also come across and become part of that Gaussian splatting. So it becomes sort of a stage, in a way, Blender, where you can set up your scene with multiple elements, with perfect lighting control, and it's not just it would be very hard to do that as a standard 3D model, let's say. Then you can export afterward.
And because the Gaussian splatting has this quality that it can also show the reflections and these transparent things. It is the benefit in there that you can enjoy these qualities in real time after you have made a rendered model out of the synthetic material out of the. But the synthetic material also comes with that because we are doing this inside the 3D program, we are also able to capture the information about the placement of the cameras and all the camera information in there, and also the so-called sparse point cloud, which is the quite interesting aspect of the whole Gaussian process. There are these three cornerstone elements that you need to proceed with the Gaussian model. There is these image sets, the source images, then you have to have the camera information, the coordinates about where the cameras are when the images are taken, and also what quality cameras, how wide the lenses, and all that information. And then there is this third aspect, which is this sparse point cloud, which only acts as a kind of a 3D guide for the Gaussian. It is not so connected to the final result, but the sparse point cloud gives the information about the 3D space where the Gaussian should be gathered in there. And with that, with changing the sparse point cloud and playing with the sparse point cloud, you can get very interesting results that the Gaussians can be produced even though the sparse point cloud doesn't represent the actual object that you have made. And through that method, I also have now found this new quite visual thing that which I call the Gaussian propagating. I just very recently found this aspect about the Gaussian training. The PostShot program have been very great because it has this live preview where you can really see how the Gaussians are generating and how they are building themselves, how the algorithm is writing all these Gaussians in their places in the 3D space. But they have been gathering around this very, very lagging kind of a very short frame rate kind of a thing, until I noticed that if you push the play button in the timeline during the training process, the cue point starts to run on the timeline, and it refreshes the viewport more frequently, and you will start to see those very dynamic Gaussian placement, that the Gaussians start to wobble around and they will go on their places very dynamically and like growing in the algorithm pace. And also there is this very interesting pulse-like this pulse kind of an error happening in there, that each, I don't know, is it a 100 iteration step, the model will refresh itself, and it makes like a heartbeat to the model in there, and it's very artistic way and a new kind of a revelation how these models are built, and putting together with this different sparse point cloud method, you can get this kind of a propagating and growing effect, that the Gaussians are like appearing from the different surfaces you can control where they are starting to grow, or even if you use some other 3D object where you take the sparse point cloud out, they can start producing from the touch of another point cloud, and I have made this animation about those thinking that a touch of two different kind of 3D objects will start this propagating effect.
And I think there is a fascinating element into this, in a sense, something that is very, very technical in a way, shows still like a sense of being alive, right? When you mention pulsating, right? Technology doesn't pulse really. It's more like human, or let's say entities that pulse, like energy pulse, right?
Yeah.
So and I think this has another elements where we are dealing with this different kind of I wouldn't even say file format, but like this different type of captures, right? And this could be point cloud, it could be nerves, it could be Gaussian splatting, but in general, turn them and discover how their properties can also be used to, in a sense, as a form of art. That I have, for example, here an example. Let me share it from a capture that I've seen recently that I think is actually quite impressive, in a sense that let me. I think it's this. Yeah. So in this sense, you have this capture and it tells a story, right? And it uses this property of Gaussian splatting and how this was used to capture movement, and something that it is somehow kind of like a bug, a bit like what you were describing about this pulsing and pushing the play button, turns into what is kind of like a feature. So how do you see this technology like also being used for their properties in order to, let's say, find a new way to express artistic concept or maybe tell stories?
Yeah, or this can also bring something that we don't see in there. They can reveal things that we don't normally see in our perspective. Those images are like a 3D long exposure things that you can do. You have been able to do those kind of images with the normal camera with the long exposure time, and the Eric who have done those very nice 3D experiments with his very brilliant multi-camera rigs and have done multiple of those very artistic kind of 3D scans have done wonderful job in there to bring all these new dimensions to those artistic expression styles. But I believe that there are still going to be a huge amount of these kind of new revelations when we start processing with these things. Unfortunately, there are not so. This propagating effect can be only recorded out from the PostShot viewport.
Yeah, and
When
this is another
when we,
example. This
yeah,
is another
yeah,
example I'm sharing. This is like from Ruben Frosali. It's Ruben Fro
yes,
is also, and he's a master overall in point cloud manipulation and making this incredible effect. And I
yeah,
think that one of the elements is also this ability to animate this particle, right, and tell these stories. And I know, for example, that Kiri Engine has also the add-on for Blender also allowed to play around with this animation of particles. So, for example, like morphing a Gaussian splat into another, for example, right? I've seen some example, and I think this opens up a lot of opportunities that go beyond just using this tech to scan the real world and obtain one-on-one representation of reality. Okay, now we can do it, but boring to some extent, right? We have this technology that can do so much. Maybe like creative minds can actually build on top of it. And when we talk about creativity, I think one thing maybe we should also touch upon is this concept about 4DGS, right? In the sense that these splats that can actually come alive. I wanna add a little bit another clip from your own tool and how that's being used in a camera array tool, so that maybe again you can kind of like walk us through it.
yes, yeah. Since I have been working on this camera retail tool, I also noticed that okay, this can be used for make the data sets for the animation, and of course when we are inside the Blender and these 3D software, you can render also the animations. But with the camera array tool, you can render all the images from each frames. And basically these 4D GS models, these 4D Gaussian splatting models are only a sequence of these PLY files in there. And so you can produce a Gaussian splatting model from all these frames. And of course, it's going to be huge a huge amount of file sizes afterwards, and you can't actually do much about those at the moment. This is very new thing at the moment. In PostShot newest version, there is only the possibility to display those animation when it can show the Gaussian these PLY sequences in the PostShot. But that's about it. You can't save it in any format yet, and there are very limited opportunities to put them on the VR headset or use them anywhere. But the interest about this have been very huge, and many of my clients or my users who have bought my add-on have been interested about exactly about this aspect, and I believe in the game engines or different kind of where you need some short clips about animated 3D models. These can be actually be quite interesting to use, and the development happens on that side.
And of course, I mean, for everybody, you will find the link to the camera array tool in the description so that anybody who wants to check it out can actually give it a look. One question that I have is who are the people that have gotten these tools, right? Or that maybe you are in contact with and they are reaching out. So what are they doing with it?
Yeah, it's been very interesting to watch what kind of. There is a lot of these hobbyists who are very interested about and they are Blender uses. But then there are these. I have noticed that there are these gaming studios who have bought the and that they are making experiments or researching these opportunities, what you can get. But also, I have noticed that some creative minds have been used the array tool for different purposes that they produce material for AI recreation, that they can make these renders about the very simple 3D object, and then they can put these data sets to the AI and enhance the pictures through the AI process and make very crazy like 3D model through that method. And it's totally open. That I'm very happy that people found different kind of usage for the data sets and all those images which you can render from the object with this tool, and I hope that we will see some results very soon, that people will come out that they have really used that in their project.
And I think it's a very interesting point in the sense that it is so. I felt that in a way before we kind of like had an idea of how the workflow would go from 2D to 3D and then maybe to a gaming engine. I think that now things are all mixing up in a sense, because the moment that you can create this synthetic data more easily and then you can use them, for example, to train an AI model, maybe to generate 2D images, right? So
yeah.
at the end, there are so many angles in which everybody is leverage their own knowledge and expertise into their fields and trying to get the most out of it and putting this together. And I think yours, it's a very interesting and down to earth implementing in something that we already know, being of course Blender, to start creating these splats, not just using these expensive rigs and dozens of cameras. So that makes things radically different and more accessible.
Yeah, exactly. And even if you are just designing and wondering about how would I build this such a camera rig, you can use that tool for designing those things and calculate that, okay, perhaps 20 cameras is enough or something like that. It can be used many different ways, and that I believe that there are some other aspects also in there which can be done. But especially I designed it to this process where you can use the data sets for the Gaussian splatting training, but perhaps in the future you can always use those data sets for all kind of purposes. And it's a very cool to have that kind of a chance that you can. I have also noticed that I can, even though that I will produce mostly the synthetic material out of that, but also that people who have done the real world 4D GS scannings from those rigs, they have the benefits from the camera array tool, and they have understand the process, what happens in there. And I have also helped a few of those people who have done and compared the real world material to the synthetic material, and we have found some solutions through that, how the so-called call map data should be written and copied to the frame folders and that kind of solutions in there that can be connected with the real and synthetic world.
It becomes a sort of like a prototyping, right? So you can do this test, right, in order to see how that's going to behave in the real world. I do have one last question, and that is, since I do I've discovered that the Vision Pro now has become more of a tool to see splats in VR because it's more powerful than other things or movies. So I think it's a very great device for that. And I just wish there would be more, or still they would be more streamlined, because still, even on a Vision Pro, it's not always easy to experience them. Lags, and also the experience when being in these, let's say, apps or tools, it's very suboptimal. What do you think is needed to get basically to increasing the use of Gaussian splatting in AR or VR? What does it take?
Well, perhaps like we have discussed in this discussion earlier, that the file size problem has to be resolved, of course, and the decent compression method that you can really upload and download these files very quickly should be solved. But also, if there is going to be some sort of a standard, I haven't had the opportunity to use the Vision Pro yet, but I have studied and watched all those YouTube videos about it, and then there are, of course, these Meta Quest classes and all different kind of a PC VR headsets where you get the power from your PC CPU to use the goggles with the wire on them. But also it has also already shown that the Gaussian splatting models can be as light and as quality to run even in the standalone headsets, and because already for example, the Quest 3 has very, very nice new XR features in there, and probably the good way right now is to test those super splat gallery that the Play Canvas has just now released, that new gallery where the people who produce this Gaussian splatting model, you can publish your own Gaussian models in there, and there is this opportunity to check out how it looks in XR mode. If it's only an object, you can see it in your table or anything with the Quest classes, but it can be quite laggy still, and it's very early in its development, but it looks very promising. And I think that this kind of a simple services that you can just go in one web link or web address and open these models, and it's a very simple concept, but it can make a lot of nice things in Absolutely. There, and then open the opportunities.
And I've done some research. Actually, I found 11 tools or apps that allow to watch splats in VR. I made a list for anybody interested that want to check it out. If you subscribe to the newsletter, also the link is in the description. You will find that there are indeed various solutions, being Super Splat, being Gaussian, but being others that I didn't even know about. So I think there are indeed some opportunities. Some can be laggy, so you need to have a strong stomach to experience it. But for sure, do it and check it out if you're interested. Awesome. Olli, thank you very much. Check out his channel, absolutely. It will also be a link in the description. And thank you very much for being with us.
Thank you for having me.
Thank you very much for listening in. If you like the show, remember to leave a rating on Spotify, Apple Podcasts, or a thumbs up on YouTube. It really helps me keep doing this and shine the spotlights on the greatest founders and makers, pushing the boundaries of XR and AI. Also, make sure to check out the show page xraispotlight.com, where you can find more conversation like this one. Till next time.